Okay, first we'll look at these. I've got 2x squared plus 11x plus 15. There's a few different ways you could do it. I'm going to show you one of the methods. The method that I like to do is called the AC method. It's not the only method, but it's just a reliable method to use. So I'm going to do 2 times by 15 first, which is 30. So I'm looking for two numbers that multiply to make 30, and they're going to add to make this 11. So it's kind of similar to how you do these ones. You look for two numbers that multiply to make 12, and they have to add to make 8. But here they multiply, you do 2 times 15 first, that's what they're going to multiply to, and they're going to add to make 11. What would the two numbers be?
6 and 5.
Yeah, 6 and 5. Can you see that this is a 2? So I'm going to have two brackets, and I'm going to put 2x there, and I'm going to put 2x there. And because I got 6 and 5, I'll put plus 6 and plus 5. Now, if I expanded this out, 2x times 2x would give me 4x squared. So I don't want that. I need to simplify these brackets if I can. So I can see everything here divides by 2. This one, it doesn't have a common factor, so I can't divide that one. So I'm going to divide everything there by 2, and I get x plus 3 and 2x plus 5. And if you expanded that out, you would get that one.
Okay.
Just make a note of that, and then we'll do another one together.
There we go.
Cool. I'm going to do H next. I'm going to show you a different method for E, because that one's a little bit easier. So what's the first thing that we do?
Times it by 5.
Yeah, 5 times 5 is 25. So we're looking for two numbers that make 25. What do they add to make?
26.
Good. They're going to be quite close together. What are they? No, they're going to be quite far apart from each other.
25 and 1.
Yeah, 25 and 1. So in the first bracket, I put 5x plus 25. In the second bracket, I put 5x plus 1. Can you simplify either of these?
The first one,
Yeah, what would it be?
x plus 5.
Yeah, good. And the other one just stays the same. And quick way you could check it, x times 5x, it gives you 5x squared, and 5 times 1 gives you 5. So that's kind of a quick check of how to do it. Do you think you could do k on your own?
Yeah, I'll try.
Okay. If you need help, just tell me.
Do I have to do 2 times 36?
Yeah, that's right. What have you got so far?
2x plus 9, and then 2x plus 8.
Yeah, just simplify that one.
Okay.
That's what you should get. And 9 times 4 gives you 36. 2 times 1 gives you 2, so probably right. We'll take a look at B. What two numbers would you multiply together?
7 and minus 3.
Yeah, very good. Okay, you can try that one. Tell me when you've got an answer.
I can't work out. What did you do after I got minus 21?
So times to make minus 21, what do they add to make?
20.
Yeah. What would they be? Think about your factors of 21. What are your factors of 21?
7, 3.
Yeah, it's only one more.
One.
Yeah, 1 and 21.
Yeah.
So it's not going to be these because that doesn't really make sense to get the negative 21. But how do we get positive 20? Which way around should it be?
1 minus 1 plus 21.
Yeah, that's correct. So then we've got 7x minus 1 and 7x plus 21. And then one of these will simplify.
And the second one.
Yeah. What would it be?
X plus 3.
Yeah, good. How could you check it?
3 times minus 1.
Yeah. That looks right. And that looks right. Just do one more. This one's quite interesting. This number is a prime number, so that makes it a little bit easier because we know the two numbers that make 1 is going to be 1, and the two numbers that make 3 will be 3 and 1. So we could just do 3x in one bracket to get that 3x, and in the other bracket is going to be x, because 3x times x gives us x squared. Because both of this is just 1, both of these will have to be just plus 1. So that makes it a little bit easier. Could do the same thing with, let's see if I got another one. 2x squared plus 7x plus 5. So because it's a 2x squared, what will these first terms be?
2x and x.
Yeah. And then we want 5, so you don't have to tell me the order that they're in, but what would go on the ends here?
Is it 3 and 2?
They're times in to make 5.
I don't know.
Just two numbers that times to make 5.
2 and 2.5.
No, you forgot about it the last time as well. I think when you did, where was it? This one, when you did 21, you forgot 1 and 21.
Oh yeah.
So what would it be for 5?
1 and 5.
Yeah, 1 and 5. So now you just kind of play around a little bit. Either it's going to be a plus 1 here or a plus 5. And we can see we want 17x. So we want quite a large number of x's. So I think I would try the 5 over here first, because 5 times by 2x gives 10x. Doesn't work. No, that's not the question. I'm looking at the wrong question. I'm looking at this question. Let me just rewrite it out. 2x squared plus 7x plus 5. So you said 2x, you said x, and the numbers are going to be 5 and 1. So we want to try and get 7x. So which side do you think the 5 goes in?
The second one?
Yeah, the right hand side. So that'd be the plus 5 and that'd be the plus 1. So sometimes if you can see prime numbers like that one, even this one, you could probably do just by looking at it. You don't have to do those extra steps. Well, that's just like a quick recap of factorizing quadratics. Today we're going to look at a couple of different theorems. We're looking at the remainder and the factor theorem, and then we'll look at some division if we get time. So I just want to take a look at these. If I said this was equal to 0, so it's an equation, and I substituted in x equals -6, what would happen to this?
I don't know.
What would happen if I swapped that with a -6?
Be 0.
Yeah, because that one would be 0, and anything times by 0 would be 0. So x is not x equals -6 means that if I substituted if I substitute -6 into here, that would give me 0, and that tells me that x plus 6 is a factor. So we're going to look at that kind of thinking. So here we've got a slightly more trickier one, where this is a normal question that you might get asked at higher. So show that x minus 1 is a factor of 2x cubed minus 3x squared minus x plus 2. So this is just called a polynomial, because we've got some cubes, we've got some squares, we've got some different terms going on. It's just a polynomial. The way we can show this, if we think back to here, this was a factor of that, and this was a factor of that. So that's telling us if I substitute in -6 into here, that would equal 0. Might not make sense, but I'll explain. It will make more sense here. So here it says x minus 1 is a factor. So if I call this f of x, so it's a function, just going to call this 2x cubed minus 3x squared minus x plus 2. I know this is a factor, so if I substitute 1, because if I had x minus 1 is 0, x would equal 1. If I substitute 1 into that, we'll do it together. So 2 multiplied by 1 cubed minus 3 multiplied by 1 squared minus 1 plus 2. 1 cubed is 1 times 2. 1 squared is 1 times 3 minus 3 minus 1 plus 2. So 2 add 2 is 4, minus 3 minus 1 is 0. So this is showing if I substitute the inverse of that when x is 1, I get 0. So this is called the factor theorem. So if I substitute something into here and it gives me 0, that tells me that this is a factor of this. That means that this can be divided by this. So the main thing that you need to know is this. If f of a, if you substitute something into the polynomial and you get 0, then what we saw here, x minus 1, would be a factor of it. So I'll just copy that one out. I'll just make a note of what I just showed you.
Okay. Or just copy.
I think the bottom one's okay. So it's basically saying if I substitute something in and I get 0, that means it's a factor. If I don't get 0 when I substitute it in, that means it's not a factor. That means I've been left with a remainder.
Okay.
Just tell me when you wrote that. We'll look at a few more examples.
What's my role?
Cool. Alright. I'll do a few more examples so it makes more sense. The one on the bottom says, what is the remainder when x squared minus 3x plus 2 is divided by x minus 2? So I could do this using division, but I could use these theorems to help me. So because I've got x minus 2, the opposite of that will just be 2. So if I substitute f of 2 into here, let's see what we get. We get 2 squared minus 3 times by 2 plus 2. Just work that out for me.
Is 0.
Yeah, good. Because it's 0, this is telling me that x minus 2 is a factor of this. If I didn't get 0, that means it's not a factor. If I get a remainder, that means it's not, yeah, if I get a remainder, it's not a factor. What is the remainder when x cubed plus 2x is divided by x plus 3? What do you think we need to substitute in here?
Minus 3.
Yeah, minus 3. Okay, have a go at that.
Is it 33?
Let's see, so negative 3 cubed, that'd be 9, and then minus 27. And then negative 3 times 2 is negative 6. So it's negative 33, not 33. Did you substitute in 3?
No. I thought I done minus 3 squared. I thought it was just 27.
Okay, so minus 3. What's minus 3 times minus 3?
9.
Yeah, and then 9 times negative 3.
Minus 27.
Yeah, that's why. And then if you times it again, you'd get positive 81. So if it's a odd power, you're going to get a negative answer. If it's a positive power, you'd get a, sorry, if it's a even power, so if it was a 4, then it would be a positive answer. So because we got minus 33, is this a factor of this?
No.
Yeah, good. All right, let's have a look at these. For number 1, what would I substitute in?
2.
Yeah, good. What would it be? You can just do it in your head.
5.
Yeah, is it a factor? No. Okay. Try number 2. You can write this one down.
Is it minus 4?
Let's see. So I would substitute in minus 1. So minus 1, 1, minus 1. Oh, I think you made a mistake here. I think you did minus 1 times by 3.
Oh.
Just check that again. It's cubed, not times by 3.
So 0.
It's okay. Minus 1, 1, minus 1. So minus 1 cubed, what does that give you?
Minus 1.
Yeah. So we've got minus 1 minus minus 1, which is 0. So is this a factor?
Yeah.
Yeah. For this next one, it's a little bit trickier. It says 2x minus 1. So do you remember when we had these? Let's say we were trying to solve this. We've got 2x plus 5 and x plus 1 equals 0. So if we want to find out what x is, we do 2x plus 5 is equal to 0, and then we solve that. So we take away 5, and then we divide by 2. So it'd be negative 5 over 2. That makes sense what I did there.
Yeah.
Alright, so here we've got 2x minus 1. If we had 2x minus 1 equals 0, what would x be?
Minus 1 over 2.
Not minus 1. If you move this minus 1 over to the other side, it's going to be positive 1. So it'd be 1 over 2, or half. That makes sense? Okay, so we're going to substitute in a half into here. So have a go at that one. You got an answer?
Is it 3.5?
3.5. No, that's no. What's a half times a half? Write out 1/2 times 1/2. How do you multiply fractions?
I can't remember how you do it again.
That's okay. Multiplying fractions is the easiest one out of them. You just multiply across. 2 times 3 would be 6. 3 times 5 would be 15. So it's the easiest one.
Yeah.
So half times a half is?
2 over 4.
That bit's right. 1 times 1.
1 over 4.
Yeah, 1 over 4. And then if we add 1 to that, what do you get?
1 1/4.
Yeah, very good. You could write it as 1 1/4. I'd probably write it as 1.25 or 5/4. I think they'd be easier to work with, these two. So 5/4, so then it's not a factor. I think we've practiced enough of these, but I'll give you this PowerPoint if you want to look after the lesson.
Okay.
You can. Let's look at this question over here. It says x minus 5 is a factor of this. And we've got x cubed minus 6x squared plus ax. So we have another variable here. We're trying to find another letter, minus 20. Work out the value of a. Because it's told us it's a factor, when I substitute 5 in, what would this equal?
0.
Yeah. So I'm going to substitute 5 in, and that'll help us find the value of a. So we've got 5 cubed minus 6 in bracket 5 squared plus a, I should have wrote 5 lots of a, minus 20. That makes sense what I did?
Yeah.
Okay. And because we know it's a factor, it's going to be equal to 0. And now we're just solving to find a. So it's quite simple. 5 times 5, 25, times by 5, 125. 5 squared, 25, times by 6 is 150. Plus 5a minus 20. We'll just clean up this. So we've got 125 minus 20, 105. minus 150, which is, I think it's minus 45. So 5a minus 45 equals 0. Well, let me just check that. Minus 150 minus 20. Yeah, that's right. Okay, just solve that. What would a equal? What do you think? Or do you want help?
Would it be 9?
Yeah, 9's right. 5a equals 45, a equals 9. So we could put that in there, and if we substituted 5 into there, it should equal 0. You don't have to do this, but how would you do that question?
I'm not sure. I'll explain it.
Okay. Remember when we did these? If we substituted 2 in and we got 0, that means it's a factor. So the way we would show it is if f of 1, and it says it's a factor, when I substitute 1 in, it should equal 0. And when I substitute 4 in, it should equal 0. So just test that. You're going to substitute both of those in, and it should equal 0.
Okay. Yeah, the first one equals 0.
Yep. You don't have to do the next one. Could you do number 3? I showed you an example. This was the example that we did before. That's quite similar to that one. And if you want to use a calculator, you can. What have you got so far?
64 plus 32
Yeah.
plus 8.
Plus 4a.
Yeah.
Yeah. What's it equal to?
What does A equal to?
Because it's a factor, what would it be equal to? This left-hand side. Zero. Yeah, 0. And now you can solve it.
A would be 5, would it?
Not 5, but close. So, yeah.
Minus 5.
Yeah, because 4a equals negative 20. Just be careful, because I've noticed you've done that a couple of times. So a would be negative 5. Just tell me how you do number 2. You don't have to do it.
B. So then 2 for x.
What should you get?
2 cubed. 0.
Yeah, you don't have to do it. I'm going to do this question here. So we've got a polynomial, but we have x's, we have a, and we have b. So we're probably going to have to find a and b. So that's our f of x. 2 of the factors are x minus 2 and x plus 3. And it says work out the values of a and b. So I'll do this as an example, and then you can try one. So I need to substitute both of these in and then I'm going to get two equations. So we'll see what happens. So I'm going to substitute 2 in first for that one. So I've got 2 cubed plus, remember I got to substitute this x as well. So 2 squared, which is 4, so it's 4a, plus 2b plus 24. That will make sense. 2 cubed is 8, so I could write it as 32 plus 4a plus 2b, and all of this will be equal to 0 because I got told it's a factor. And then I'm going to do the same thing with negative 3. So I'm going to do f of minus 3, which is negative 3 cubed. Negative 3 squared is 9, so 9a. Then I've got negative 3b plus 24. That's minus 27 plus 24 minus 3. So it's minus 3 plus 9a minus 3b, which is equal to 0. What do you think we have to do now that we've got these two equations?
Is there a simultaneous equation?
Yeah, very good. Let me write it somewhere else. So I'll put it up here. So I've got 32 plus 4a plus 2b equals 0. And then I've got minus 3 plus 9a minus 3b equals 0. What do you notice about this first equation, the top one?
Um,
32, 4 and 2, what do you notice? Anything in common with them?
common factors.
Yeah, which common factor?
8.
8 is not a factor of 2. It's 8 is a factor of 4 or 2. It's a multiple of 2 or 4, but it's not a factor. Factors are what you can divide by, and multiples are basically your times tables. What's the common factor of 32, 4 and 2?
I don't know.
What could you divide them all by? You probably learned this when you were 7 or 8.
1.
1, yeah, there's one other option.
Is it 2?
Yeah, it's 2. They're all even. You don't have to do this, but I think it just makes it a little bit easier because it gives you smaller numbers. So I'm going to divide everything here by 2. I got 16 plus 2a plus b equals 0. And then what's common with all of these?
It can be divided by 3.
Yeah, good. So I'll divide all of that by 3. I've got minus 1 plus 3a minus b equals 0. And now we can solve them simultaneously. So I'll probably move that. So I've got 2a plus b equals negative 16. I'll just move that 16 over, and then I'll write it as 3a minus b equals positive 1. And then what would I do with these two equations?
Take them away from each other.
Not take them away, because b take away negative b would give me 2b.
Add them.
Yeah, I'm going to add them. So 5a is equal to negative 15. A would be equal to negative 3. And then we can find out what b is. So negative 6. B is going to be negative 10. So quite a few steps here. we'll try one together. I first substituted 2 in, and I substituted -3 in, and I made it equal to 0. I then got these two equations, and I just wrote them over here. I didn't have to divide it by 2 and 3, but just to make it a little bit easier for later on, it just helped. So if you can simplify them, but if you can't, or if you don't want to, it's not a problem at all. But it'll just make this bit a little bit harder, and then we just solve these simultaneous equations. I think you're okay with that bit. Maybe just this bit might need some work on, but we'll see. Let me copy this question. Just give me a second. Okay, have a read of it and then tell me what we should do.
Substitute them in.
Yeah, what would I substitute in?
1 and -2.
Okay, go for it, and then I'll help you after you've done that bit. You done the first one?
Yeah.
Okay, I'll write it down. I can check it. So it'll be 1a, so a minus 1 minus 2. I've just wrote it like that to make it easier. I got a plus b equals 7.
Yeah, that's the same.
Okay, tell me when you've done that next one. I'll do it. That's what I got for the next one. I haven't simplified it yet.
Yeah.
Okay, so I get minus 8a plus b minus a plus 2, so minus 2. And then if I just bring it all together, I get minus 8a plus b equals minus 2. With these, are you going to add them together or are you going to take them away?
Take them away.
Yeah, good. Tell me when you've got a and b.
Okay. I've wrote them like the other way around from you. Does that matter?
I actually think it's better if you wrote it the other way around. I was just thinking about it. So if I write it minus 8a plus b equals minus 2, it's better if I take them away like this. You don't have to write it like this, but you can just think about it in your head. Because I'm going to do a minus negative 8a, it's going to give me a positive. So it's better if I do it that way. But if I did the other way, minus 8a minus a would give me minus 9a. So it's better to do it that way, the way that you wrote.
What would 8a minus 8a be?
You got a minus negative 8a. So what does that become?
Yeah. Is it just positive 8?
Yeah, it's plus 8. A plus 8a, which is 9a. So you've got 9a for the left, and then 7 take away -2.
9 equals 5.
7 take away -2.
9.
Yeah.
So A equals 1.
Yeah, good. B is.
B would equal 7.
No, put it in here.
No.
A is 1.
Six.
Yeah, 6. How do you think you could check this? I haven't showed you it. I'm just seeing how you're thinking.
I'm not sure.
Okay. Because we know A and B, if I rewrite this out with A and B, so A is 1, so that's nice, x cubed minus 2x squared minus 5x, and B is 6, I could use this, and if I substitute 1 into here, I should get 0, and if I substitute -2 into here, I should get 0. Alright, we'll stop there, but I think that's a nice little start. We did a little bit on factorizing quadratics and a little bit on factor theorem. I'll put this PowerPoint and I'll give you some extra questions on these because I think you should practice them. I think just for yourself, it might be useful just for you to go over factors, multiples, and your negatives, and solving equations. There's a few mistakes that I've seen you make during the lesson, so I think it might be worthwhile for you just before you start next year, look at these topics, because you don't want to be having to relearn these next year, because the level of the maths is going to be more like this, and you don't really want to be making mistakes with stuff like that anymore. Okay?
Okay.
Alright, any questions before I go?
No.
Cool.
Alright.
Alright, thank you, Cole. I'll see you next time.
Thanks. See ya.
Bye.
Bye.